It's the material of choice for millions of water bottles. PET, polyethylene terephthalate, has been around for decades. But what could the water bottle of the future look like? And what are producers like Nestlé Waters doing to make sure their bottles don't end up polluting the environment? I've been speaking with two of Nestlé Waters' leading polymer chemists about their work to make bottles even better for the consumer and the planet.
All the benefits that we will develop by making PET a better material will benefit the entire industry and the entire world, which is really what we want to achieve. Imagine that we could make plastic, no longer sourcing the ingredients that are used for making PET coming from petrochemicals, but having them from sustainably managed renewable resources like wood waste, like food waste.
Plastic from food waste. That seems a bit like science fiction. Jean-François Briouat runs the group responsible for quality, material science and sustainability at Nestlé Waters, and Charlize Poutot researches bioplastics and biopolymers for Nestlé. What makes a good water bottle?
For the water bottles, you need to have different properties. First is to protect the product, to be sure that the product will be the same at the end of the shelf life, to be neutral, and to have design aspect, for example, to be more visible on the shelves. For that, you can use different material. The first one is plastics. So plastic is not only used to produce the bottle, but also all the secondary packaging, label, for example, but also the cap. You can have also a glass bottle and also aluminum cans. Each kind of packaging has different attributes. For example, glass is considered as premium, but is heavier and can break as well. PET, it's a good material because it is unbreakable, it is light. All these materials are really recyclable, so it's really a good point for the water industry.
Glass has the highest collection rate. Glass is as recyclable as aluminum cans and as PET bottles, but for a reason which is most probably connected to the fact that glass has been out there on the market for many, many years, so people are more used to bring it back so that it is collected. It's maybe because glass is so heavy. People value it maybe more than plastic, PET, which is much lighter for the same volume of packaged product. So this may be the reason why such differences in collection rates for these different packaging material, but they are all recyclable, provided that people just bring them back through the different collection schemes that they can use.
You mentioned glass being heavier than PET. Assuming they're both recycled, does the weight of the bottle have a big impact on the environment?
We have to take into account when comparing one solution to another one. The primary packaging could be glass, PET, or cans. Then we have to take into account the secondary packaging, so the way we sell the bottles together. And then the tertiary, so the packaging which is needed to bring the bottle from a factory to a retail store. So all this has to be taken into account. But definitely, glass, it's much heavier per unit of product sold. Second, just to produce one, let's say, kilogram of glass, you need much more energy than what you will need for 1 kilogram of PET. So at the end of the day, having a much heavier bottle does impact the environmental performance of the bottle itself. The thing is, the heavier your container per unit of water sold, the more transport. And when you say transport, you mean the more greenhouse gas emission, the more particle emissions. So transport is a significant part of the global environmental performance of a bottle. For glass, because it's so heavy, this share of the environmental performance becomes pretty significant. And depending on the type of distribution radius that exists between the center of production of the bottle and where it is consumed and returned for recycling, there is definitely a limit for which PET becomes a much better option. Above 250 kilometers from distribution point, glass cannot win in terms of environmental performance versus PET.
Charlize, how can you improve the circularity of PET and further prove the importance of recycling?
First is to decrease and optimize the weight of the PET bottle. For example, Vitel is a brand from Nestlé Waters. Since 25 years, Vittel decreased by 40% of the weight of its bottle with the same mechanical properties, with the same convenience of the bottle. So it's a great demonstration that we were able to improve the life cycle and the environmental impact of a bottle. The improvement of the life cycle is not only optimize weight, it's also increasing the collection rate. And that point is really, really important to improve the life cycle of our material. For example, in France, 1 ton of recycled PET can save 1 year of energy consumption of 2 families. And it can save as well 2 tons of CO2. So I think that increasing the collection rate is really important.
So the motivation to recycle isn't just about reusing the plastic. It's about changing the whole way we look at energy consumption and the amount of CO2 we produce.
Exactly, and what people must remember is that every single time they bring some bottle back for collection and recycling, they avoid the production of virgin material, which extract fossil resources from the environment, which is critical. In other words, all these used PET bottles, they are not a waste. They really are a resource because they are as if this material had one life, which was the bottle that we've just drunk. And then by bringing it back and making it recycled, it would have many, many cycles of this material in its history. Empty PET bottles are not waste, they really are a resource. On energy standpoint, on greenhouse gas emission standpoint, they will avoid the production of virgin material.
How important is it to explain to consumers how they can best use and recycle this plastic to make PET truly sustainable?
There's a large share of education that must be done, and we should be part of this education. We bring on the marketplace some packaging material, so our duty is really to communicate about it. For too many years, maybe we assumed that we did not have to because it was kind of we expected it to be obvious, but it is not. And that's the reason why you may have seen more and more communication on label, direct communication to our consumer, inviting them to bring all bottles back for collection and for recycling. This really makes sense. But again, now we have really understood that we have a role to play and we should be more proactive in making this message clear to our consumers. Our job as scientists and technical experts is really to find ways to make the situation even better than what it is today. We are very lucky to be working in such category where, by the way, which is the most advanced in terms of collection rate of any other categories. Beverage bottle is a category for which collection rates are the highest. PET is a plastic material which is the most collected and most recycled in the world. So this is a great accomplishment already, but we want to make it even better. So our share is just to find this new different way and then share it and explain it as best as we can to our communication colleagues, which will then translate all these technical features into really easy to understand messages to our consumers so that they can also see the value of the work that we do and maybe feel less guilty whenever they drink water from a bottle because they should not. It's a great product. And if consumed responsibly, then it will be collected for recycling and the environmental performance of this consumption will be much better.
Charlize, your work at Nestlé focuses on new ways to make plastics with other renewable materials. Can you tell us more?
PET is made of 2 components, monoethylene glycol and purified terephthalic acid. For the moment, these 2 components are coming from oil, but instead of using material that is coming from oil, we are working on materials coming from renewable resources, bio-based PET, like byproduct of food production. Chemically, it's the same molecules, and at the end of the day, you will be able to produce exactly the same PET. So it's not a miracle, I would say, but it's just the difference will be the origin of the molecules. The properties of the PET will be exactly the same.
We have identified 2 ways to make PET a better material, and we are working now actively with our competitors because we believe that all the benefits that we will develop by making PET a better material will benefit to the entire industry and to the entire world, which is really what we want to achieve. So these 2 ways are, there's one which has already been very well explained by Charlize, which is no longer sourcing the ingredients that are used for making PET, no longer having them coming from petrochemicals, but having them from sustainably managed renewable resources like wood waste, like agricultural waste, food waste. Imagine that we could make plastic out of them. And the other way is to making this recycling process more and more efficient. So this we're working both for mechanical recycling, but also for this new enhanced recycling technology, making the bottle and every single PET packaging also circular by making them recyclable, whatever the design of the packaging. Would it be a simple PET bottle, which is currently already fully recyclable by design, or more sophisticated packaging based on PET with multi-layer, with plenty of additives, which cannot currently be recycled by means of mechanical recycling technology and require this enhanced recycling technologies.
Are there other types of plastics you're researching alongside bio-based PET?
So we work on other alternatives material to find the best option for our category. The first material that we are working, alternative material, is a PEF, which is a 100% bio-based material. It's chemically close to PET, but with better barrier performance. Just to explain you a little bit, it will help to phase out complex and difficult to recycle packaging. Another material we are working on as well is PHA. This material is a bio-based material from renewable resources that is as well recyclable. And the advantage of this material is that it can degrade in a much shorter time than PET. But PHA is also a plastic, is a polymer material. But we have microorganisms that you can find in the nature, can cut the polymer chain and can degrade naturally the material by different microorganisms that you can find everywhere, even in ocean and in water. Each time we are studying a new material, what is really important is to verify, to check that from environmental point of view, it is as well better. So we really need to validate that there is a globally better environmental performance.
How long will it take before these new polymers can be used globally and replace traditional PET?
This is a very good question indeed. If only we knew.
The sooner as possible, let's say,
Yeah.
but it's not so simple because, as we said from the beginning, PET is really a good material and we try not to lose convenience that we have with PET. And it's not so easy with alternative materials because we will not reach all the characteristics of the PET. It's really the objective of our work to optimize the functionalities of bottles made with this material.
Today we need also scale. I mean, all these developments, some of them are at lab scale. Just to make it from lab to an industrial facility for packaging will require time. Even so, it already takes some time to build a pilot just to produce a few kilograms of a material which would be turned into a bottle. But just build a factory to make thousands of tons of this material in a very efficient way, because at the end of the day, there's no need to produce PHA or PEF if at the end of the day it is more impacting the environment than properly designed PET bottles. So for this, we often speak about ecology of scale. So you need to reach a certain scale to be environmentally efficient enough. We have benefited from recent breakthrough in this different technology. I mean, a few years ago, this would not have been possible because the science was not there. But recently, there's been some kind of an acceleration, and we are currently benefiting this, and we are really supporting, as brand owners, all this development. So that's the reason why we team up with startups and are supporting their effort, funding their effort, but also bringing some technical expertise so that they develop the right product for the right categories.
What's the message you want to see on water bottles for everybody to read and take notice of?
What I would like to convey to people and to our consumers is that they should trust us as Nestlé Waters. We are working very hard and pushing very hard to really further improve the environmental performance of our products. It's something that is really, really important for the future.
If I may build on this, I would say that all this good work that Charlie has presented only makes sense if people are convinced that once empty, a PET bottle is not a waste, it is a resource. I do not believe that it would come to anybody's mind just to throw an empty glass bottle in the street. So why should we do this with a PET bottle? It's the same. It must be collected and recycled. I mean, today, the vast majority of the PET items are already recyclable by design. We are working hard on making things better, but everything starts with collecting all these PET items out there. And this is really, for me, the key message. If you want it to be circular, we are working on the circularity of the ingredient used by the PET. We are working on improving the recyclability of PET. But for doing this, PET bottles must first be collected to be recycled.
That's a long message on a bottle. Jean-François Brouillois and Charlize Poutot. Thank you for listening to Nestlé's Together for Circularity podcast. If you want to find out more about Nestlé Waters and sustainability, go to nestléwaters.com and click on See What We Do. I'm Alistair Elphick, and this has been a Modulated Media